Hey guys, so I'm continuing what we were talking about today in class. It's section 6.2 and it's solving equations using trig functions. And so I want to remind you of a couple of things. What we talked about in class today and what is written on the front page of this notes page was to give your answers in terms of 0 to 360, which means the entire unit circle, or 0 to 2 pi, which means the entire unit circle. So just keep that in mind that these questions are not restrictions. We're following the directions that were on the beginning of the page. The only time we do restrictions is when you see those little -1 symbols, those inverses, or those the arc sine, arc tan, arc cos, those things. That's your clue to use the restrictions. In this case, we're following directions and just using the entire unit circle. And so a lot of times these are going to be like review problems. What you want to do is combine like terms, and we're trying to get like the trig function by itself so that we can then use the unit circle to give an answer in terms of radians or degrees. So keep in mind this is an x, so since it doesn't say radians or degrees, I'm going to use radians. It's when you see a theta, you're going to use degrees. Okay, so all I'm going to do here is I'm going to combine my like terms. And I'm going to cancel that. That gives me secant x plus 1 equals 3. Which means secant of x equals 2, which means cosine of x equals 1/2 because those are reciprocals. So there are two places in the unit circle where the cosine of x, that's the x value, is 1/2. And in terms of radians, that's going to be a 60-degree reference angle. So that means I'm at pi over 3. And the other one is in quadrant 4. So that answer would be 5 pi over 3. So again, just review stuff, you guys. We've talked about this before. You guys know the unit circle. All we're doing is we are looking for x values where the cosine of x equals 1/2. So those are radians again because they gave me the question in terms of x. Number 2, so remember all the strategies we have for factoring. The first thing I notice when I see this problem is that both terms have a cosine in them. So what I'm going to do is factor out a cosine of x and just see if that helps me solve it. That leaves 2 cosine of x minus radical 3 equals 0. And so I'm going to have two different equations now to solve for x. One of them is to set cosine of x equal to 0. The other one is to set the parentheses equal to 0. So that's going to be my two different equations. I know I can solve this using the unit circle. Where is the x value equal to 0? There's two places. Another one is 2 cosine of x minus radical 3 equals 0. So I can clean that one up a little bit. Cosine of x equals radical 3 over 2. When you add the radical 3 over and you divide by the 2, you get radical 3 over 2. That's another unit circle question. So again, this question is in terms of x, so I'm going to do radians here. In this case, for cosine of x equals 0, where is the x value equal to 0? I get pi over 2 and also 3 pi over 2. So remember, we're not doing restrictions here, and my answers don't have to be in terms of like negative pi over 2, positive pi over 2, whatever. We're just using the regular unit circle, 0 to 2 pi. These are the two answers. Don't think too hard about it. Okay, and then where is the x value? Radical 3 over 2. So that is a 30-degree reference angle. So that means x equals pi over 6. And also in quadrant 4, the answer is 11 pi over 6. Check your unit circle with me. You can have it out as I'm going through this video so you can verify, but that's the answer for number 2. There are 4 answers, these two and these two. Okay, moving right along. Let's look at this one. So one strategy here, you guys, I know what you might automatically think to do is to start foiling. But when your equation is already equal to 0, you don't want to FOIL it out. We actually want it factored. I can set this factor equal to 0 and this factor equal to 0. So it actually saved me a step. So very first part, cosecant of x plus 2 equals 0. Or I also have cosecant of x minus radical 2 equals 0. Those are my two equations I'm going to solve. This means cosecant of x equals -2, which means sine of x equals -1/2. So remember, those are reciprocal functions. They're equivalent. I can just find the radian measure for sine of x equals -1/2. Same thing here, cosecant of x equals positive radical 2, which means when you flip that and rationalize it, you can pause the video and check my work on that. You get radical 2 over 2. When you flip this, which is radical 2 over 1, that means you need to rationalize it. Okay, so the two places I'm looking in the unit circle here are wherever the x value, or y value, excuse me, because we're doing sign, that's y value equals negative 1/2. So I'm in quadrant 3 and quadrant 4. And in radians, that's going to be a 30-degree reference angle. So that means 7 pi over 6. And also 11 pi over 6. Those are my 30-degree reference angles where the y value equals negative 1/2. And then on this side, where is the y value radical 2 over 2? So that's positive, so that means I'm in quadrant 1 and quadrant 2. So it's a 45-degree reference angle, which would be pi over 4. And in quadrant 2, it is 3 pi over 4. So I have 4 answers for this one. Look these up on your unit circles as I'm going through these so you can make sure that you're understanding where I'm getting these numbers from. But it's just unit circle stuff. Figure out if it's y or x, and then move on from there. And again, these are x's, which is why I'm assuming they're doing radians because it wasn't given in the degrees. When you see theta is when you do degrees. All right, this one, kind of a trick question, but first thing I think of is just to try and get the tangent of x, tangent squared of x by itself. That means I gotta move over the 3. And what you need to recognize here, this is not a trick question, but can anything ever be squared and also equal a negative number? Not really. So this is a huge clue for you to stop and pause. This is another Algebra 2 topic. This is not possible. I know what you're thinking, but we can have positive and negative tangents, but not tangent squareds. So another way that you might want to think about this is if you didn't recognize that a function squared can't equal a negative number, maybe what you were thinking of was to try and square root both sides. When you do that, don't you get an imaginary number? So the reason for that is because this is non-real when you square root both sides. So just keep that in mind. I think there's a few Math Excel questions where it's like a multiple choice answer where you have to say non-real answer or not possible or something, but here's an example of that. So just kind of stay on your toes as you're plowing your way through all of these equations that we're solving, okay? So there is no possible solution for this one. Number 5 is a lot like number 3 where it's already factored. What you might be tempted to do is try and FOIL this, but our equation is equal to 0. Let's set this equal to 0 and this equal to 0 and help us find our answers. So I'm going to do cotangent of theta minus radical 3 equals 0. That's the first equation I'm going to solve. And I'm also going to do 2 sine theta plus radical 3 equals 0. That's my second equation I'm going to solve. You just set each parenthesis equal to 0. Try to avoid foiling it out because you'll end up refactoring it and maybe making a mistake somewhere. It takes way longer. So this means cotangent of theta equals positive radical 3, which using the reciprocal function, because I think better in terms of tangent and not cotangent, if I flip that and rationalize, I get radical 3 over 3. There are two places where degrees now, keep that in mind because it's thetas, where the tangent of theta is radical 3 over 3. And that means that it's a 30-degree reference angle, so I'm in quadrant 1 at 30 degrees. And I'm also in quadrant 3, which is 210 degrees. So those are my first two answers for this side. Moving over to this side, when I get the sine theta by itself, I get negative radical 3 over 2. And so that means where is the y value? Negative radical 3 over 2. Those are 60-degree reference angles, and it's in quadrant 3 and quadrant 4. So 60-degree reference angle in quadrant 3 is 240. 60-degree reference angle in quadrant 4 is 300. And remember, I'm looking at the unit circle in this case where the y value is equal to negative radical 3 over 2. Okay, I believe there are two more that I want to look at. Let's talk about this one. This one is kind of a trick. This one is a little bit harder. What you're going to want to do is star this one because there is a trick in order to solve this. What I'm going to do is change this into 1 over sine theta because I want to have the same function in on each side of the equation. That's just a trick, something that you might not recognize right away, but I'm going to leave the left-hand side of the equation the way that it is. And I'm going to change the cosecant of theta into 1 over sine of theta. And then from Algebra 2, what you should recognize is how to clear fractions in this case, or you could also think about it in terms of cross multiplying. I'm going to multiply both sides by sine theta. This is a tough algebra question here. What that means is I'm going to distribute my sine theta on this side, so that gives me 2 sine squared theta minus 1 sine theta. And on the right-hand side, my sine thetas cancel, which is what I wanted. I wanted to clear the fractions, and I get equals 1. So now I'm going to move everything over to one side so that I get 0 on the other side, and I'm going to try and factor the left-hand side. So I know this probably factors. I got to use my strategies for factoring here. And in this case, when I FOIL this out, 2 sine squared minus 2 plus 1 gives me my negative sine theta in the middle, and then positive 1 times negative 1 is negative 1 here. So those are my two different equations. I finally got it factored, and I got it into something that I can easily solve. This means 2 sine theta plus 1 equals 0, and sine theta minus 1 equals 0. So I can solve both of these equations, subtract the 1, divide by 2, and sine theta equals positive 1 over here. So where is the y value on the unit circle in terms of degrees? Equal to negative 1/2. That's quadrant 3 and quadrant 4. And when the y value is 1/2, that's our 30-degree reference angle. So I have 210 degrees and 330. In this case, where is the y value equal to positive 1? In that case, that's only 90 degrees. There we go. So just one more question that I want to do, you guys. This one is a quadratic formula question, which we decided to eliminate from the chapter, so we're not going to do that one. You can just cross it out and enjoy crossing it out, because we're just going to skip that. But let's go over to number 7. This will be our last one. So first thing I notice about number 7, again, remember your strategies for factoring. In this case, I have a tangent squared in each term of the equation. So what I'm going to do, I'm just going to try it. I'm going to try and factor out the tangent squared of theta. That's going to give me 2 sine theta minus 1 equals 0. And now what I can do is set tangent squared equal to 0, and I can set the parentheses also equal to 0. So tangent squared theta equals 0. That's going to give me a couple answers. I can square root both sides here and just get regular tangent of theta equals 0. I'm also going to do 2 sine theta minus 1 equals 0, which means sine theta equals 1/2, which we've done earlier in the worksheet. Okay, so where in the tangent of theta, remember tangent is y over x. And so I don't want to know where is it undefined, so I'm not looking at where's the x value equal to 0. I want to know where the y value equals 0. So that is 2 places. That is 0 degrees, and that is 180 degrees. That's where the y value equals 0. In this case, where the y value for sine equals 1/2, that's a 30-degree reference angle, and it's in quadrant 1 and quadrant 2 since it's positive. I'm at 30 degrees, and I'm at 150 degrees. And that concludes solving equations, you guys. Good job. We'll do a lot more practice in class tomorrow and make sure you got it. Have a great night.